Good evening, everyone. Wait for some more minutes so that everyone else joins. Okay, everyone. So I am audible, right? Good evening, everyone.
Yes.
Good evening.
Yes, okay. So this is the week 4 of the discussion session, and till now we have completed up to week 4 um, assignments. So today I'll be discussing week 5. Okay, so first, like last um, discussion session itself, I'll start with some basic questions which you have already seen in the recorded sessions. So we'll start with that and then I'll discuss the assignment questions. Okay. So constraints optimization. So last week 4 you had seen unconstrained optimization. The functions that we examined were unconstrained, meaning that they had no boundaries or the boundaries were soft boundaries. Okay, now what you are having is that you have a constraint optimization, means that there is a hard limit based on the value of a variable. So this can mean, like, for in a real life example, this can mean like if you're having traveling in a car from Surat to Mumbai and you are adding the stop. Okay, so in the navigation, if you are adding a stop in between, that is like a constraint. So and for this example I have given like Nashik, so it will be like to go through that place, you'll have it is like a constraint placed on your journey. Okay, so the unconstrained situation will show a path like this, and if you have put a constraint like must visit Nashik city, then it is showing this way. Okay, so this is like some real life example of having an unconstrained and constrained problem. Okay, so this is another example. Like a task of problem is like climb as high as possible on the mountain to have a better view of the moon. Okay, so actually as high as possible is at the top of the hill. Okay, but if you are putting like the car must be on the road, then it's like you should have a you should have this road itself. I mean that road should be there and it should be the highest place in that road. Okay, so that is one kind of a constraint. Okay, so equality constraint optimization. So this week you have seen equality, inequality constraint, everything you have seen. So first, last week we had the unconstrained minimum. So this is like, I mean, for an example, I have given like minimize in two variables x1 and x2, 2x1 square plus 4x2 square. So that is the region. So the minimum of this region is given by this one. That is the unconstrained minimum. Now, if you are placing a constraint like 3x1 plus 2x2 equal to 12, then this is the line there. So if this region is constrained by this particular equation, then the minimum will fall in this shown by this yellow star. Okay, that is equality. So it's like the constraint is equal to a particular value, so you'll be getting a line. Now, similar kind of example we have seen in last week itself. So I'm just refreshing a little bit. So this is like for a rectangle whose perimeter is 20 meter, find the dimension that will maximize the area. So let us consider the breadth and length, area and perimeter. So this all you know. So the objective is like you have to maximize area. So area is given by length into breadth, and such that the perimeter is given by perimeter, that is 2l plus b, 2 into l plus b. equal to 20. Okay, so as you have seen in the equality constraint, applying the first order condition, this one, okay, rad of f is 1 equal to minus lambda into this one. Okay, so then you can calculate it like, um, I mean, the first one will be like, um, okay, so the first one, so the maximize f of x from this one. Okay, people are joining. Sorry for the interruption in between. Um, okay, so the thing is like, first you have to see this f of xy is a equal to l into b. Okay, so if you see like dou f by dou l, then it will be like dou f by dou l will be like b, and dou g by dou l, okay, will be like 2 lambda, right? So the equation, the condition, that is one thing. Then the next thing equated will be like, um, next thing will be dou f by dou b. That means it will be like L equal to minus lambda into this one. So there you'll be getting the similar thing, L equal to minus 2 lambda. And the other constraint is like 2L plus 2B equal to 20. All right. So these are the three equations that you are getting. So if you solve these two equations, you will get L equal to B. Okay. So that is the case when you solve equation 1 and 2 and putting this value in equation, this thing, then you will be getting like, L equal to 5 meter, and y meter we have already told it as 20 meter. So anyway, that is there. So then you will be getting these two equations. Okay, I mean, from these two equations you will be getting the area of the rectangle is 5 into 5 equal to 25. Okay, so just a minute. Okay, so you'll be getting these things, and area will be like 25. Okay, now find the points on the circle. So the circle is given. So this is like a similar question will be coming in your assignment also. So you can listen to this one and we can solve the next one later. So here is like equation of a circle is given, like x square plus y square is equal to 80. Okay, so this is just a representative figure. Okay, so which are closest to and farther from the point 1 2. So you have a point and you have this condition. Okay, so distance from any point xy to the point 1 2 is given by d equal to in this form, right? So now you can tell like, you can maximize this equation as maximize f of xy equal to x minus 1 whole square plus y minus 2 the whole square, that you can put. Okay, in equation you can mention like that. And you already have the circle equation, which is g of xy equal to x square plus y square equal to 80. Okay, these two equations you're having. So if you apply the first order condition is like this one. Okay, if it is applied, that means that you have to find out dou f by dou x. Dou f by dou x is 2 into x minus 1. Dou f by dou y equal to 2 into y minus 2. Then dou g by dou x equal to 2 into x. Yes, and dou g by dou y is 2y itself. Okay, so these four equations will be getting. Now you can find out, like, putting all derivatives in the main first order equation gives like, so this is, you can solve it by many different methods. So now it's coming like, you have to put first thing like 2, okay, 2 into x minus 1 equal to minus 2 lambda x. Similarly, 2 into y minus 2 equal to minus 2 lambda y. So this will give you, if you solve that, okay, that means like x minus 1 by x is equal to minus lambda, and y minus 2 by y equal to minus lambda. Okay, and the other condition is like x square plus y square equal to 80. Okay, so if you solve these two equations, equation 1, equation 2, if you solve, you will be getting like, okay, you can solve these two equations. So you can check that later, and the answer is coming like y equal to 2x. Okay, now this value, if you substitute in equation 3, then you'll be getting like, I mean, y is equal to 2x you got. So if you solve this one, then you will be getting like this value. Okay, I mean, x square will come like 16, then x will be plus or minus 4, and from there y value also you'll be getting like, for x equal to 4, y equal to 8. So the points we have obtained is 4, 8, as well as minus 4, minus 8. So now what you can do is like, you can just, I mean, you can put in the equation and see, okay, which is the point, which is the distance, I mean, distance d from any point to the point. We have already mentioned like d equal to root. Okay, so there you can put and see which is the, which is having closest one and farthest one. But if you see, there is another method also. Anyway, you know the point 1, 2, then just in a Cartesian point of view, if you just plot these points, you can just find out which is farther and which is closest. Okay, you can find in that method also. Okay, the correct method is like, you have to put in the equation and see. Okay, so till now I think it's clear for everyone. If clear, yes, Ayush, tell Ayush. Ayush, what is your question? Repeat this question. Do you mean? Okay. Okay. So we have to like, we have points on a circle, x square plus y square minus 80. Okay. I mean, that means like x square plus y square equal to 80. Sorry, equal to 80. That is the circle. Okay. Which are closest to and farthest from the point 1, 2. Okay. So this is a circle. We have a point 1, 2. Have to find out the points which are closer in the circle, which are closer to the point. Okay, so First, we know that distance d from any point x5 to the point 1, 2 is like d equal to this one. Okay, x minus 1 whole square plus y minus 2 the whole square. That is the distance from the equation. So we are just taking the function from that one. Okay, x actually is like root, but we don't require that. Okay, maximize, we have taken that function like this one. X minus 1. So it can be seen like the equation of that line also. I mean, okay. So we are taking that function x minus 1. Is it possible to draw and explain? Drawing meaning like uh, so I didn't quite understand. Okay.
So if you can draw in a notepad or some paint or so that it will be easy for to understand.
Okay. So what part you need? I mean, the equations are pretty straightforward only. Okay. So okay. Is it not clear in the PPT?
PPT it is clear, but it is we are not following where you are mentioning that point where you are mentioning. So if you can draw a circle in a paint or something, so it will be easy for to capture it.
Okay. I mean, the circle we have here, right? Okay. Wait. So this is our circle actually. It's just a representation only. It's not scale to the actual units. Okay. So this is the circle that is given by this equation. So wait a moment. So here the equation of the circle is given like x square plus y square equal to 80. So this is like equation of a circle. Yes, with radius. How much can be the radius? What is the normal equation of a circle? X square plus
Root
y square.
root 80. Root 80.
Yeah. So that is the normal equation. So this is like this is a circle. There is center, no centers are given, like x minus nothing is present. Okay. So it's like the center is at 0, 0. So this is the circle with center 0, 0 and radius root 80. Okay. So this is a circle. Okay. And in the circle, we are given the question, the one point is given like 1 comma 2. Okay, that point is given. So it's this point is lying in between. Okay, and it is asked like find the points on the circle. So it should be like these points should be on this circle only. Okay, it should be on the circle itself, and which is from farthest to this point as well as closer to this point. Okay, so anyway these can mean like to this till like that. Then if the point you are finding is like this, then this is the distance between these 2 points. Okay, so we don't know the point. Okay, we don't know the points which are closer to this point and farthest from this point. Okay, the condition is like these points should be in the circle. Okay, so I hope the question is clear
So
now.
that's on the perimeter of the circle, right?
It is on, yeah, it's on that circumference. It should be
Oh,
on the circle.
okay, clear.
Yeah. So this point is there inside. Then we have to find the points on the circle. Okay. So then we know that between 2 points, what is the distance between? from any point x comma y. So we don't know the point, right? We don't know the closest as well as farthest point. So if you have any point x5 to the point 1 2, then the distance between them is given by this equation. Okay, so for that we are taking like f of xy equal to x minus 1 whole square plus y minus 2 whole square. So we are taking like maximize right now. Okay. Anyway, so we are taking the equation like this one, and the equation of the circle is given by x square plus y square is equal to 80. Okay. Now, so your first order conditions will be like this one. Okay. This del of x f of xy, I mean grad of f of xy equal to minus lambda of g f of xy. Okay. This is the condition. Okay. So this grad of f of xy means that dou f by dou x and dou f by dou y, right? This is that one. And then this of g of xy means dou of, so that is written there wrong, okay? It came like and. So dou of g by dou x and dou of g by dou y. Okay, so we need to find all both these things. So in the first one, it is like dou f by dou x will be 2 into x minus 1. Okay, so that is the first one, 2 into x minus 1. And the next one is 2 into y minus 2. Both these you'll be getting. The next one, dou g by dou x, dou g by dou y, that will be coming like will be 2x and 2y. Okay, so according to our condition we need to equate it. Okay, so if you equate it, it will be coming like 2x minus 1. Okay, it will be coming like 2 into x minus 1 equal to 2x. Okay, coming like 2x. And the next one, if you equate it, so lambda I have missed, sorry, 2 into y minus 2 equal to minus lambda into 2y. Here also minus lambda will come. So if you solve this equation, I mean if you rearrange it, you will be getting x minus 1 by x equal to minus lambda, and the other one y minus 2 by y equal to minus lambda. Okay, now you can solve for this one. So it will be like x minus 1 minus lambda x equal to 0. Sorry, x minus 1 plus lambda x equal to 0. That means like 1 plus lambda into x equal to 1. So x equal to 1 by 1 plus lambda it will be coming. Okay. Then here it will be coming like y minus 2 equal to minus lambda y, then 1 plus lambda into y equals to 2, y equal to 2, then y equal to 2 by 1 plus lambda. That means that, so from this you can find out like y is equal to 2 times x, because x is equal to 1 by 1 plus lambda, so y is equal to 2x. Okay, now that is, so that leads to this uh, step actually, y equal to 2x. Sorry. Okay, so that comes to this level, y equal to 2x. Then this value is substituted in equation 3. Equation 3 means this particular equation. Okay, So we are just giving like x square plus y, we are substituting like 2x whole square equal to 80. That means like x is equal to plus or minus 4. Then putting the x values in the equation, 3 give y equal to plus or minus 8. Okay, so like these 2 points you'll be getting. So you can solve it anyway. You can find the lambda value also and then solve, or you can solve like this. Okay, so now if you, when you put in this equation, you will be getting these particular values. Okay, x equal to plus or minus 4, y equal to plus or minus 8. So one point is like 4 comma 8. When x equal to 4, then y equal to 2 into 4 like 8. So this is one point, and this is one of the points, and the other point is like minus 4 and minus 8. So anyway, we got 2 points on the circle. We got 2 points on the circle. Okay, now we have to find out which one is the farthest and which one is the closest. Okay, so there is this much distance between here and this much distance here. So one method is like you substitute this point. Like for example, 4 and 8, if you substitute, you will be getting like 3 square and 6 square. 3 square plus 6 square, root of that one. Okay, so some distance you'll be getting. Now similarly, when you are putting like minus 4 and minus 8, so you'll be getting one higher value, like it will be then 20, it will be coming like 25 plus 100, 125. Root 125 will be coming. In the other case, 3 square plus 6 square, it's like 9 plus 36. Okay, so the values are coming. So you have to find out which is the minimum distance and which is the maximum distance. Ayush, when I'm writing on the screen, it is not visible. Are you? Is that for same for everyone?
Yes, it is visible.
You can view.
It is visible, madam.
Okay, okay. Ayush, it's visible. People are telling.
Yes, madam. It's visible and clear. You can continue, madam.
You can continue, madam. It is visible and clear.
Okay, okay. So, I mean, now we have got the farthest point as well as the nearest point. Okay. From the figure itself, I mean, 1.1 comma 2 is in the first quadrant as well as 4 comma 8. The minus value is like in the negative quadrant. So, so you can find out which is having the minimum distance as well as the maximum distance. Ayush, I don't know the what is the problem at your end. Maybe you can leave and join again and see. Okay. So I hope the others are clear with the equation, with the question.
Clear, clear, madam.
Okay. So we'll move on to the next one. So the next one is like another question: f of x, y, z equal to x plus z, and g of x, y, z equal to x square plus y square plus z square minus 1. Okay, minus 1. Okay. So anyway, you can put it as like equal to 1 or minus 1 equal to 0. Okay. So then we can apply the first order condition. Okay, so the first order condition is like we have already seen. Okay, so I think yeah, so first one is like df by dou f by dou x, dou f by dou y, and dou f by dou z will be coming like 1 0 and 1. Okay, then the next one, the other one, dou g by dou x, dou g by dou y, and dou g by dou z will be coming like how will it be coming? First one, I mean 2x, then 2y, then 2z. Okay, so if you give these in this equation, you'll be getting like 1 equal to minus 2 lambda x and 0 equal to minus 2 lambda y, 1 equal to minus 2 lambda z. Okay, so so now in equation, so if you solve 1 and 3, I mean already you will get like either y equal to 0. Okay, y equal to 0 will be getting with equation 2, and looking at first equation 1 and 3, you'll be getting like x equal to z. Okay, so all these things we'll be substituting here in this equation. So in this equation, x square itself, y square 0, and this one x square equal to 1. This one will be coming like that. So x value you will be getting like plus or minus root 1 by 2. Okay, so when x is plus 1 root 1 by 2, z is equal also that one. X is equal to minus root 1 by 2, z is also minus root 1 by 2. So you'll be getting 2 points. Okay, point 1 and point 2. Okay, now so this is the equations. Okay, I mean the points which are calculated with the given constraint. Okay, now you had also seen inequality constraint. That was like, I mean these two equations you'll be having earlier. Okay, but here the difference will be like there will be some inequality condition. It won't be equal to 12. In your earlier conditions, you are getting like equal to 12 and minimize a particular problem. Now it will be like this particular thing is there, and you have to show that this is greater than or equal to 12 or less than or equal to 12. Okay, that will be the constraint. So similarly, this one, the unconstrained minimum is here. The constraint minimum is like here when you are just considering the line, but depending on the equation, okay, whether it is less than 12, then it will be coming in this region, and greater than 12, it will be coming in the other region. Okay, so you have to consider that also. This thing is given like constraint minimum is given like which is the point of that region lying on that line. Okay, right now your inequality is like greater than, so it will be changing. Okay, now multivariate inequality constraint, this you have seen in the pre-recorded lectures. So I mean minimize a certain region is there, then you have certain constraints given which are inequality constraint. So first one is like 3x1 plus 2x2 equal to 12. That line is drawn there, and less than or equal to 12 is given. So this is below this line is the region. Then 2x1 plus 5x2 equal to 10. That is also less than. Okay, so so like this it is given. Okay, it should be less than like and less than like in that value. The next one equal to 1 in this region. Okay, so this is like this is a small, that's the figure is drawn for greater than or equal to 10. Okay, so that we have to see, and x1 less than or equal to 1 will be coming, so this will be the feasible region. Okay, so now this also you have seen. Okay, this is also an example which is taken from your recorded videos itself. So mm, you might have a problem like this: minimize 2x1 square plus 4x2 square, and then you will be getting two conditions like this: less than 12, greater than 10. This one was shown there in your pre-recorded lectures. Okay, that's the same example. So you might have seen the Lagrangian. It will show like this one plus mu1 into this particular thing. Okay, And so everything, can anyone tell me how we will arrange this one, this Lagrangian? Because one of your equation is like less than 12 and the other one is like greater than 10. So okay, so you have to rearrange this one like, yeah, multiply minus 1, yeah. Or it's like, so your second equation was like 2x1 plus 5x2 greater than or equal to 10. Now, so you have to see like, you can bring it the other way, 10 minus 2x1 minus 5x2. Okay, this side will be 0. Okay, so 10 minus 2x1 minus 5x2 less than 0, because here also it was like 3x1 plus 2x2 minus 12 less than or equal to 0. Okay, so these two conditions, then this one x1 minus 1 less than or equal to 0. Okay, so the first order KKT conditions will be like, I think you have seen this there. Okay, so the first one you have to see for dou by this one, I mean the Lagrangian, you have to differentiate with respect to x1. Okay, so if you do it with respect to, so this is like L dash. Okay, so it is coming like, first thing with respect to x, if you do, then it will be coming like from here, sorry, from here, and so from 2x1 it will be coming like 4x1, I mean 2x1 square will be coming like 4x1, then 3 mu1 x1, 3 mu1 x1 will be coming like 3 mu1, and from here minus 2 mu2, okay, minus 2 mu2, and from here mu3 equal to 0. That will be the first one. Now in the second one, with respect to x2, it will be coming like 8x2 will be coming here from here. And okay, Nanmata, what's your doubt?
How does 2x1 square have become 4x1?
Differentiate with respect to x1.
Okay, ma'am.
Yeah, so you have to calculate like this, dou L by dou x1 and dou L by dou x2. Okay, that is given here. So Lagrangian with respect to x1 is given in this one. Then with respect to x2 is given here. Okay. So then you have these other conditions. Okay, mu1 into 3x1 plus 2x2 minus 12 equal to 0. Mu2 into 10 minus 2x1 minus 5x2 equal to 0. And mu3 into x1 minus x3 minus, okay, sorry, it is x1 minus 1. x1 minus 1 equal to 0. Okay, and this is another condition which is required. I mean, all mu I should be greater than 0, greater than or equal to 0. So there are many ways by which you can solve this. You have seen in the lectures itself. Okay, so it was shown as a table of how you can do. Like you had given like active constraint, inactive constraint. I hope you remember. So just I'll show, like if mu1 you are taking as 0. Okay, there are many ways to solve this constraint equations, because you have 5 equations here, right? So one method is like, you have to consider which mu values you are taking as 0. So if mu1 equal is taken as 0, then this 3x1 plus 2x2 minus 12 equal to x minus 12 is taken as an active constraint, and you have to include that in your problem solving process, okay, to find the solution. Okay, now if you take like mu1 equal to mu2 equal to 0, if you are, so like that if you are taking, then the other one can't be 0. That is the method. Okay, I mean that is the intention. So from there you can see, like you had seen this in the recorded lecture, you had seen this one. Okay. The first one, like if all the ones are active. Okay, if all the ones are active, then okay, so here just comparing it that, so I think in the lecture they started with the fifth problem, fifth step, I think. Okay, just take that laser pointer. So here you see, in the fifth step, it's like um, active constraint and inactive constraint. The first one is active, the other two are inactive. So just go through this one. I mean, these are the constraints. These are the three constraints. So in this one, mu1, in that particular condition, mu2 equal to mu3 equal to 0. Okay. So in this particular problem, if mu2 and mu3 equal to 0, this particular things are not there. So they are considered as inactive constraints. So this first constraint and second constraint are coming as inactive, and only one constraint is active. Okay, so mu1 you are not considering as mu1 you are not considering as okay. So right now the equations will be like, in the first case, okay, in the fifth case your equations will be equation this one, first one, then second one. Okay, and it will be mu2 and mu3 you are considered as 0. Okay, mu1 you haven't considered as 0, so that means that 3x1 plus 2x2 minus 12 equal to 0. That is one equation. So this particular constraint is active, the others are inactive. Okay. So these three equations. So these three equations will be used to solve the other two. So, and in this first one, it will be coming like, just for an example, the first one will be going like 4x1 plus 3 mu1 is present because it's not 0. Mu2 is 0, not present, and mu3 equal to 0, not present. So the first equation will become like this one, and the second equation will be coming like 8x2 plus 2 mu1, mu2 equal to 0. So this is the other equation. So these three you have to solve. Okay, so when you had solved these three, you were getting the x value, x is to know means x1 and x2. Okay, value you are getting like 3.27, 1.09, and mu value, only one mu1 is there. Okay, mu2 and okay, just I'll write here mu2 equal to mu3 equal to 0 in that case. Okay, so in that case only that minus 4.36 you had got like mu1, and x values you got like this. Okay, so I hope, I mean, we had gone through this, like why is it not satisfied in this case, because you see one condition that we had to satisfy was this one, x1 should be less than or equal to 1. Okay, but when you solve this particular these set of equations, when you are solving these set of equations, okay, when you're solving this set of equations, you got x1 as 3.27. Okay, next to as 1.79. Okay, so that is why this particular, I mean, in this particular problem, x1 less than or minus 1 is not satisfied. So it's not the possible optima. Okay. Now, similarly, you can check for each of the different possible combinations. Okay. So the first thing is like all are active constraints. So all are active constraints means here it's like mu1 considered as 0 equal to mu2 equal to mu3. Okay, I think this also you can see here. That means that okay, I will show it with a figure, but anyway, you will be you will know that you can know that like all three lines will not be meeting at a single point, right? So it's infeasible. Now, when you had given what you can say, like for many different things, here also when you are calculating with one active constraint for second equation and other two inactive, like here mu1 equal to 0 and equal to 0 and mu3 equal to 0 you were taking. So in that example, you had solved the other equations and got x equal to 1.21 and y equal to 1.51. So here also x1 is not satisfied. So these many conditions are there. So only place where you are getting an optimal solution is this one. Here you can see that here other two constraints are active only mu1 equal to 0. Okay, so others you have come they are coming like 2.56 and 1.12, and then x values are coming like this. So x1 less than 1, that constraint is satisfied here. So all constraint and KKT conditions are satisfied. So that's why that particular solution is optimal. Okay, so this is the different cases, the figures for the different cases. This also was given in the pre-recorded lecture itself. Okay, so if you have to refer more on that, just you can visit those lectures. So here the three line condition, so it's not possible that the three lines will intersect at a single point. That was not possible. Then just wait a moment. Okay, so here you can see here these two lines, well, they are meeting at this point. Okay, and the others are meeting at other two lines are meeting at another point, this one. Okay, so our optimal condition is this one, where the two stars shown in the pink and white color are meeting at the same point. Okay, so this is the optimal place shown by this particular step. Okay, the fourth step. Okay, so I think till now it's fine for everyone, right? Okay, if anyone has any doubt, tell me. Otherwise, we'll move on to the assignment questions. Ah, yes. Like that, it will change. Yes, Aditya, that's right. Okay, so anyone else? Yes, it's available. Okay, so I think it's okay with everyone. We'll move on to the assignment questions. Okay, this might be similar to your assignments also. So the first one is like maximum of f of x is the objective function you have to consider. So this question, it's same for first and 2. Okay, the same question applies to questions 1 and 2. Okay, so maximize f of xy equal to xy subject to these conditions. Okay, x plus y square less than 2, x comma y greater than 0. The Lagrangian function is given in this form. Okay, so here xy greater than 0, that is there. Then to this one, just Aditya, you can also see here how we are rearranging. So first one is like xy, that is true. Okay, same, minus mu1 into, we have to arrange it in the form of the equation. So it's like maximize. So it came like 2 already there, like greater than or equal to 2 is there. So that is there. Then you bring the others in that side. Okay, that is why it is coming in this form. All right, Aditya. Okay, so you rearrange that equation. Yeah, so rearrange the equation like 0 less than or equal to 2 minus x minus y square. Okay, so you change like that, and the other Lagrangian minus 2 x greater than 0, y greater than 0. That's why minus mu 2 into x and minus mu 3 into y. This is the Lagrangian. Okay, now Lagrangian function is given. So which one of the following is not an apt representation of the constraint? You can say the answer from this. There is no calculation required. Can you tell me which of the following is not an apt representation? I'll give you some time. Which are already there here, x plus y square less than or equal to 2. Okay, that is already there. First one is already there. It's my question is not an apt representation.
Second one, madam. Second one.
Yeah. 3. What is wrong with 3, Kangana? So this can be like second one. You see, second one can be translated like x less than or equal to 0, right? When you remove the sign, when you bring the sign to the other thing. And the third one can be changed like x greater than or equal to 0, right? When you bring the equations to the other side, when you bring the negative sign to the other side. Yeah, so second one is not an apt representation. Okay, the answer is this one. Okay, so you can see that the given constraint has not been mentioned as a part of the problem. That you can mention as the reason. Okay, so second one is the answer there. Now then next one, same objective function, maximize this one. Everything Lagrangian is also given. Find the values of mu1, mu2, mu3 while evaluating the KKT condition with all the constraints being inactive. So can you tell me the answer? All the constraints are inactive here. So all the constraints to be inactive means
Second one is the answer.
yes. Yeah. Okay. So you have seen from the previous example, if you are putting like mu1 equal to 0 and as well as mu2 equal to mu3 equal to 0, then your constraints are not active. Okay, these constraints won't be active if you are putting mu1, mu2, mu3 equal to 0. So this will be the answer. Okay, second option is B. So when all constraints are inactive, mu1 equal to mu2 equal to mu3 equal to 0. Okay. Now another function f of xy equal to 5x square plus 3y square plus 8xy plus 12x plus 6y as a function to be optimized, and answer question 3. Okay. Now the saddle point of the function exists in which of the following coordinates? Okay, so how to solve this one? Hmm? Narmada, what is your question, Narmada?
Ma'am, when the function is said to be in optimized condition, ma'am?
It's like you either have to see it's like maximized or minimized. Okay, and if there is no chance that it can be done either, then it will be like no solution exists. Okay, so you will be telling, so in the previous problem, maximize f of x was given, so the points which will maximize that particular function will give you the optimum solution for that problem. Okay.
Okay, ma'am.
Okay. So then Manmat has given find first order derivative, then check with points distance. Okay. There is one condition where you have to give. Can you tell? Sorry, I'll come back to that thing. You have to substitute it to something to get that point. Yeah, first order derivative you have to find. That is right. So just can you tell me what will be the first order derivative? Dou f by dou x. Dou f by dou x will be coming like 10x plus 8y plus 12 equal to 0. Oh no, sorry. That one. Yeah. And dou f by dou y equal to 6y plus 8x plus 6. Right? So what you have to do to find the points? You have got two equations here equated to 0. Okay. Two equations you have got here. You can equate these 2 points to 0. Yeah, find the solution of the equation. So you find it and tell me the answer. So the first one is like 10x plus 8y equal to minus 12. And 6y plus 8x equal to minus 6. Ma'am, I suspended. Sorry, wait. Okay. These recordings will be given in the live discussion session one, problem solving session one tab is there. So in that you'll be directed to a sheet, actually a Google Forms. In that Google Forms you'll be having the link of the Google Drive where the PPTs will be present, and also the YouTube link. For each week it will be present. Okay. Okay. So values x equal to 6, y equal to minus 9. Everyone's getting that value. Is that okay? So I hope everyone is getting that value. That is right. Okay. So x is equal to 6 and y equal to minus 9. Yeah. So what we have to do? We have to solve the equations, these two equations equal to 0 and dou f xy by dou y equal to 0. Then we will get this and we will get the saddle point as 6 comma minus 9. Okay. Yeah. Now this is, yeah, another point. Okay. So it is just asked like A circle with center origin is defined as x square plus y square is equal to 250. So we have a circle here. Okay. Find the points on the circle as at minimum distance from the point 10, comma 1. Okay. So this is a similar problem there, which we had seen there. Yeah. Yeah. Yes, sir. So this question, can you tell me how to solve this one? So first you have to form the equation, right? So your f of xy will be equal to x minus 10 the whole square plus y minus 1 the whole square. Okay. Then g of xy equal to x square, that is x square plus y square minus 250. Okay. That is f of xy and g of xy. Okay. So these equations we have. Now what is the next step? So next step is like finding these first order. So dou f by dou x, dou f by dou y, then dou g by dou x, dou g by dou y. Okay. So here you can see it in another way also, like there is an equation dou of x comma y by dou x into dou of f of xy, I mean dou of y, dou y, sorry, I have just made a mistake here. Okay. So there is an equation which you can solve. Okay, this is coming from the same thing itself. So if that like these conditions come, you can just see like dou f of xy by dou x into dou g of xy by dou y minus dou g of x comma y by dou y, sorry, dou f of x comma y by dou y into dou g of x comma y by dou x equal to 0. This is another method. It comes from the same thing itself. You can find in this method also. Okay. So just dou of by dou x will be coming like 2 into x minus 10, right? And dou g by dou y equal to 2y, right? Minus dou f of xy by dou y equal to 2 into y minus 1 into dou g by dou y equal to 2y. Okay, that into 2x. So 2x equal to 0. So when you solve this one, you'll be kind of getting like similar equation. Okay. So yeah, some had given C option. Yes. Yeah, that is right. So first one answer you have just missed. I mean, check again. Okay. So this I'll be solving once. I mean, like it will be coming like 4x minus 20. Yeah. This one also you'll be getting like minus 4xy. So from this equation we'll be getting x equal to 10y. Okay. So maybe some mistake you have made in this level. Okay, that's why Lokeshwar Reddy is getting us first on answer one. Okay. Now this is one equation. Then you have to substitute in this g of xy. Okay, so g of xy will be coming like square. Okay, so x square is like 10y. Okay, so like it will be coming like 100 y square plus y square equal to 250, and from there y will be coming like all you have got. It will be coming. Okay, okay. mm, okay, I'll come to that. So y will be coming like 1 point plus or minus 1.573. X is like 10y, that is y x is again plus or minus 15.73. Now, okay, we have to come back to anyway. So distance between 2 points, I mean, if you have x comma y as 1 point and already your given point is 10 comma 1. Okay, so distance between 2 points is given like root of x minus 10 the whole square, plus y minus 1 the whole square. So basically like x comma y, x1 comma y1 if it's you are having 2 points. Okay, the distance between them will be like root of x minus x1 the whole square plus y minus y1 the whole square. Okay, y1 the whole square. Okay, that is why we are taking the equation like that. Okay, the root is not considered there because anyway, I mean, if you square, I mean, one of the function will be like distance is like root the square of the distance. We are taking like f of xy. Anyway, minimum of this one will be minimum of the distance also, right? Okay, yeah. So just put in the equation. If first like x comma y equal to 1.573 and 15.573, I think it's 73, right? Yeah. So if this is the value, just put in this equation like 15 point, sorry, x is different. X is 15.73 and y is 1.573. So if you put in this equation, this will be coming like around 5.73 something, and right, t equal to root of like 15 minus 10, 5.73 the whole square plus 1.573 the whole square will be coming, right? That is in the first case. Okay. In the second case, it will be like d equal to, and higher value will be coming. It will be like minus 25.73 the whole square plus minus, what will be the answer? Minus like 2.73 the whole square. Okay, so anyway, if you see the distance of this point is higher and this point is less. Okay, distance of point 10 comma 1 with the first one is lesser than this one. Okay, this value like 1 value, if you have 1 and 2 values here, the value of equation 2 is greater than 1, right? Value of, okay, so then you can say like the nearest point will be, or minimum distance will be for x equal to 1.573. Sorry, I just have solved differently, right? Sorry, I'm sorry. So the answer is coming like 1, okay? And Manmat, you are right, okay? So the answer is like x equal to 115.773 and y equal to 1.73. Okay. So this will be the nearest point, minimum distance. Yes. And the farthest distance will be, the farthest one will be farthest point or maximum distance will be, yeah, it will be minus 15.733 and minus 1.573. Okay, so this is the minimum and maximum. I have just given there also. Okay, so the answer will be getting like x equal to 15.73 and y equal to 1.73. The answer is A. Okay, yeah. So I hope this is all right for everyone. If you have doubt, you can just mention. Okay, so we'll move on to the next one. So I hope it's clear with everyone. So the function is defined as f of xy is equal to 10x plus 5y plus 29. Find the maximum such that the constraint given by 5x plus 5y square is equal to 45 is satisfied using the Lagrange multiplier. Okay. So can any one of you solve this one? Have you? I think you'll be getting similar equations also. Okay. So what is, just I'll start. Okay. So f of xy is that one and g of xy is the other one. Okay. So find the maximum is asked, right? So for the maximum, you have to wait a moment. Okay, so for the maximum, the first one is like so the Lagrange's equation will come like 10y plus 10x plus 5y plus 29, and then minus lambda into the other one, or mu, like anything. Okay, so minus lambda into the one will be coming like, so this is like maximum. So 5x plus 5x 5x plus 5y square minus 44, this should be greater than or equal to 0. Okay, so it will be coming like 5x, find the maximum such that the constraint, so this is the constraint given, so 5x plus 5y square minus 44 will be coming. Okay, so okay, so the Lagrangian function if you're studying in the class, yeah. Lagrangian multiplier, using a Lagrangian multiplier means this one, that lambda which I have just given here. This one. Okay, so what you can do here, this is the function. So what is the first step? So this is like, first one is the answer. Yeah, okay. Let's wait for everyone else.
ఇప్పుడేనా స్టార్ట్ అయింది
Okay, so x comma y comma lambda, what you'll be getting? Some have given the answer. Yeah, so I'll just go fastly. So first you have to find dou L by dou x, then dou L by dou y, then dou L by dou lambda. Okay, so first one will be coming like 10 minus lambda, right, and equate that to 0. Then next one 5, the other one it will be coming like 5 minus, okay, 10 lambda y, 10 lambda y. And this one, the third one will be coming like, with respect to lambda, it will be coming like 5x minus of 5x plus 5y square minus 44. Okay, so the first one equal to 0 will give you lambda equal to 10. Then the next one equal to 0 will give you y equal to.
First
Okay.
one 10 minus 5 lambda, madam, not lambda.
Oh,
10
sorry,
minus
sorry.
5 lambda.
Yeah, sorry. That is 10 minus 5 lambda, that is correct. Then lambda will be coming like 2. Then the next one, y equal to, you'll be getting it like 0.25, right? 5 equal to
1 by 5.
20y. Is that right? 0.25, right?
Yes, madam, correct.
Yeah. So next one, this one is like 5x plus 5y square minus 44 equal to 0. Then you can find x from here. Okay. What was x in that one? X after you solve like 44 minus.
8.73.
Yeah, it's coming like 8.738. So the first answer is correct. Anyway, from y answer itself, you can see that because only one option is there with y equal to 0.25. Okay. So that is the fifth question. So I'll move on to the next one. Okay, so the next one is like manufacturer incurs a monthly fixed cost and a variable cost. Okay, so total cost incurred by him, he had to spend. I can take like total cost equal to, he has a fixed cost of 57350 and variable cost C of m. Okay, so the total cost faced by him will be like 0.001 m cube minus 2 m square plus 324 m plus that 7350. This will be the total cost. Now revenue is also given, revenue generated by selling these units. So m is like 1 unit. Okay, so selling m units, the revenue generated is given by minus 6m square plus 1065 m. Okay, so how many units produced every month will generate the maximum profit? So profit, if you give like profit of m, we have to find how many units will give maximize m for the profit. Okay, so profit is like that revenue minus the total cost of m. Okay, so that will give you your equation. Okay, so it will be coming like okay, we'll solve in this one. So it will be coming like, I'll show the options once again. Can you tell me what will be the answer? So it will be coming like minus 6m square plus 1065m, then minus the top portion. Okay, so minus 0.001 m cube plus 2m square minus 324m minus 7350. Okay, this is the whole equation equal to profit of m. Now everything is simple only. This is a simple equation. Only one variable is there, right? So you can find the answer. First, what is the step? So right now P of m is given, so you have to find dou P by dou m. Okay. So I think I need to see the question. So dou P dou P by dou m. Okay. So it will be like dou by dou m of minus 0.0001 001 sorry 001 m cube, right? Okay, let me see. M cube minus minus 6m square plus 2m square, so it will be coming like minus 4m square. Then okay, this 1065324, that will be coming like 741. Okay, 741 m, and next one will be coming. So everyone is finding, right? So yeah, next one will be coming like minus 7350. So I think I have got everything. Yeah, minus 7350 will be coming like minus 0.003 m square minus 8m plus 741. You have to equate this to 0. I mean, you have to solve this equation, and you can tell me the value for m. So m will be coming like solve this quadratic equation. I think I'm written 0.003 m square minus 8m plus 741. Yeah. So has anyone found out? Which is the option? I can show you the options also. One negative value will be coming and one positive value will be coming. Okay. So, okay, I'll tell you the answer. One of the values you'll be getting like minus 2756.28. Okay. That is the first thing you'll be getting, 0.28. And the next one you'll be getting like the value 89.61. Okay, so in your options it's given like m is equal to 46, 90, 231, 125. Okay, and the units cannot be like in the form of negative, so the answer will be like this is close to 90. So your answer will be the first option, sorry, the second option, n equal to 90. Okay, I hope it's clear. So anyway, I have given the answers once again. 2756.28. Yeah. Sorry, this is 8. Yeah. That's right. Is anyone having any doubt?
No.
Okay. Okay then. So next one, this you can tell without any solving. So can you tell me an optimization problem solved for n variables with one equality constraint will have how many equations and how many variables? Okay, Shiva is telling us B. Everyone? Okay, 2. Okay, yeah. Is that same for everyone? Okay, so that is right. Solution is B. So like this problem has n plus 1 variables, right? So n decision variables and one multiplier variable, lambda. Okay, corresponding to the constraint which can be found using n plus 1 equations like in this form, right? And one equation by solving the constraint h of x are equal to 0. So that will be like n plus 1 equations, and there are n plus 1 variables. Okay. Now let's move on to some practice questions. This you can solve and mention the answer directly. Okay. So for a function f of xy equal to 2x square minus xy plus y square minus 3 minus 5, the stationary point x comma y is, I have given a hint, you just solve and tell me the answer. So the steps will be like, you have to find dou f by dou x, dou f by dou y, and do the usual steps. Okay. So you can tell the answer. I'll start. Okay. Dou f by dou x equal to 4x minus y minus 3. And dou f by dou y equal to, it will be coming, I mean, if you try to reorder it, it will be coming like minus 4 minus x plus 2y minus 1. Okay. Solve these both equations. Okay. When you solve it, you will be getting the values for x and y. So the answer, yeah, answer is 4. That is right. The answer will be coming like 1 comma 1. True. Okay, next question. This is from the last week itself. You can immediately say how you will be getting this one. Okay, Hessian matrix for this one. So first you have to find dou f by dou x square, then dou f by dou x dou y. Then here it will be like dou f by dou x dou y will be symmetric matrix. So it will be the same, and dou f by dou y square. Tell me the answer. The 3 options are there. Yeah, Shiva, you're right. Yeah. So if you solve this one, I mean, do the second derivative with respect to x, with respect to y, and find either dou f by dou y first and then do dou f by dou x, or do the dou f by dou x first and then do dou f by dou y. Anyway, it will be the same. So we'll be getting this answer 4 minus 1 minus 1 2. Okay. Yeah, that is right. Yeah, everyone's getting the answer. Now, the next thing is like finding the eigenvalues for this matrix. That also we have discussed last week, right? So how can you find the eigenvalues? Either you can go in the normal way, like matrix, solving the matrix eigenvalue, like a minus determinant of a minus lambda I equal to 0, like that you can find the values for lambda, or you can just go to R and like it will be like, first you have to form a matrix. Okay, so matrix of this, you have to mention what is the values, like C of, you have got here 4 minus 1 minus 1 2, right? 4 minus 1 minus 1 2. So this is like number of rows equal to n row equal to number of rows equal to 2. Yes. And by row equal to, I mean, we are going by the row, so by row equal to 2. If you give this answer and store it to some variable, okay, some variable, and then what you can do is just give eigen of that value. Then you'll be getting the eigenvalues. I think I can just show there. So I think I had like this one. Yeah, just run this problem. Okay, matrix of this one and row by row equal to 2. If you run, then find what is the constant. Okay, if you do that, this is the constant. Now after that you have to give eigen, okay, of constant. You will be getting like, okay, these are the eigenvalues for 0.414 and 1.585. Okay, so let's move on to see this value. I mean, this you had already seen last week itself how to calculate the eigenvalue using R. So, yeah, this will be the answer. Okay, so I'll just go back to this one. So, the answer will be coming like 4.414, 1.585. This is, I think this is clear with everyone, right? You can use R itself to do it. Okay. Now, just find out this Hessian matrix you had already got, right? 4, -1, -1, 2. Right. How it will be, the Hessian matrix of this one? Hmm. That is right. Yeah. Positive definite. Yeah. Now, another question. This one. Yeah, Aditya, you're right. Now, the function f of x comma y equal to 2x square minus 2y square. What is the option for this one? Hmm. Yeah, D. That is the answer. Okay. You do the normal procedures. You'll be getting this answer. Yeah. So, everyone is fine with that. Okay. Yeah. So, I think all these questions you have understood, right? We'll just see some problems as we can using R, because in your week 5 itself, some data science problem, I mean, some introduction to data science was taken. Okay. So, I just want to ask you some questions. I mean, this R problem was already there, but I think after you learn week 6, we'll be going for that. Just I wanted to ask some questions. Okay, it's like a discussion. I think, just wait a moment. I will ask with one PPT actually. Okay, so just going through the concepts that you have seen in the earlier lecture. So, can you tell me what are the things that you need to take care of when you are looking at a data science problem? Or you have seen like different problems that are solved by data science. Can you tell me what are they? This was just like an introduction, right? So just you have seen just two types actually. Okay, I'll just brush through the things. So week 6 is also out, so some of you might have seen. So just problem solved by data science is usually classification, function approximation. That was told usually. Yes. Yeah. Find the required data for requirements from the data set. Okay. Yeah, optimization, data organization. Yeah. Okay, those were told. So as a or as an overview, usually when you look at some data science problems, these are the different things that you'll be seeing, like classification and regression. These are the main things you will be studying. Okay. Now, many other things are also coming like anomaly detection, recommendation, clustering, reinforcement learning. All this comes in the data science problem. Okay. So I'll just, you understand what is a classification. Okay. Meaning like categorizes a set of data into classes. Okay. Now, regression will be like predict a continuous outcome variable. Okay. So this will be having some kind of equation and you have to minimize it to that or minimize or maximize. Okay. Kind of that and then find the value. Okay. Now, anomaly is like fraud detection. I think this is, has anyone put any question? I, okay. Yeah. So this example you had seen in your lecture slides itself, like fraud detection. It was explained. Then recommendation engines that you are usually seeing. This is also another type, like offering of relevant suggestions to users based on product or service. Then clustering techniques. In machine learning, also some concepts are there. So this is like if I can have the incantation. Yeah. All the problems in data science will be like in this big thing. Okay, this will be like data science. So learning about the problem, what you need to do this, then different data cleaning methods, all will come in this data science. Then ML is a part, it's like a subset in that machine learning. So it is used to solve some of the problems in data science. Okay, but it's only a part. Okay. Now again, in between inside will come your DL, deep learning. Okay. So when AI was not asked, yeah, right, yeah, yeah. So data science will include what all things. If you have some set of problems, yeah, that is right. Yeah, so AI was not asked here, so that's why I'm not giving. So you can draw that also. So data science problems can be solved with some data science problem can be solved with your statistics also. You don't need to go for any other AI problems. Okay, so that is that data science thing. So in that data science also, it's not just solving some problems. I think I have shown some weeks before the full data science life cycle. Um, I think I'll be having it. Yeah, this one. This one was the full data science life cycle. Okay, and in that only for predictive modeling only this ML part comes. Before that, there are many other things. Data wrangling, which is called data wrangling. You meant, right? Yeah. Yeah. What do you mean by that, Manmat? Doing some operations with data, right? Where is the position of data engineering? This whole thing will be the data science life cycle or the data. Okay. So it consists of data cleaning. Yeah. So data engineering will contain like these areas where you are doing some processes to the data. Okay. First one is like forming the business understanding. Okay. Asking questions on your data that you have got. Asking questions. Okay. Like relevant information, you will be utilizing certain relevant problems. Okay. For example, you are working in a company and you are asked to increase the production. Okay. So you'll be given a set of data. So using this data, you have to find out what all operations, what all changes made, sorry, what what all changes made to your company will give you to increase the profit. Okay, increase profit. Okay, that is the first one. So then define the objectives, and objective need to be specific and clear. Now data mining will be like gathering and scraping the data from different resources. Sometimes you'll be getting in the form of certain. I'll come to that, Kankana. Okay, so this is like data mining. So you'll be getting some Excel or CSV files or different things, or you'll be getting from common databases. Okay, now data cleaning. I think missing data was taken in the recorded lecture. So there are different types of data cleaning operations to be done, like missing, duplicity, inconsistent, irrelevant, outliers, formatting. So I'll just move on to with the help of an example. Like this is a patient data set, okay? So in this data set, missing data you have already seen in your recorded lectures also. The first one is like the data set contains some missing values. Okay. So how to solve these missing values are also explained, and we'll be seeing some other methods also later. So at first it will be like you can use your normal statistics like mean, median, or mode, seeing the data. Okay, so if your data is like correctly distributed and there is no skewness, so this is your data if your data distribution is going as a normal distribution, then you can go for your mean. But if your data distribution is not in that way and if it's skewed in some other way, then you might have to go for a median for filling the values. Okay. Now it's some category, then you have to go for mode. Okay. Now that is filling missing values. There are many other methods. You have seen also some methods. We'll look at the details in the next week. And duplicity, you can understand by here itself. I mean, here it's like if duplicate rows are present, it will lead to a bias in our data. Okay, learning of the data. That is, so duplicate rows we have to remove. Then inconsistent types will be like your data is labeled, I mean, column is labeled as one value, but if the data type of that particular value is different. For example, BMI should be coming like a float value or an integer value, but it is coming here like a string value. Okay, so that is why inconsistent type. This has also to be changed, have to be changed to a new data type, like it has to be made to a float data type. And irrelevant is like in a data science problem, if you want to, this class means that whether that person has a disease or not. This in this particular data set, it's like whether that person has diabetes or not. So then in this, then the patient ID and patient number is not important, so that is irrelevant type. And outliers is some data which goes beyond the normal set. For example, the HbA1c right here is given, it will not be more than going more than 13, okay, or 14 like that. But here one higher value was given. So this higher value means that glucose value was recorded instead of HbA1c value. So that's why this outlier came in these two rows. Okay. So this is like outliers. Okay. Now going back to your um, question, Kangana. So these are the and formatting. Formatting is like, just wait for a moment. So formatting is like when you have the data set, sometimes female gender might be given in capital F, sometimes small f, and sometimes small n and capital M. Okay. So when you do the formatting, sometimes it will read like 4 different categories, but only 2 are there. Okay. So that also you have to change to one particular naming scheme. Okay. That is formatting. Then data exploration is there, that is using visuals. Then feature engineering, this is also can be called like data engineering, like construct meaningful features, select important features, data splitting and preparation. Then it will include feature creation also, and then predictive modeling. This is where our ML and DL things come. Now data visualization is the last one. So after getting some insights from the data, we'll explain or communicate with our higher authorities like bosses or someone. We'll explain that if you do this particular thing, you can maximize the company's profit. Data exploration is like, yeah. So you have created, you have cleaned the data. Okay, cleaned data, that is done. Hmm? Now what you have to do is you have to so you will be getting some data. For this example, anyway, you have removed patient ID, everything. Then what was remaining is the gender, age, urea. So one column gender. Then there is some problem with my stylus. Okay, gender, age. Okay, like that, some columns you're having. Now, I think this was explained in your recorded lectures itself. So, if in the smallest level, if you're thinking, you will have a matrix, right? So, finding relationship between the columns in the matrix is known as, you'll be analyzing that data. Okay. So, when you have a small matrix and when you have small number of columns, then you could see the rank of the matrix and then find out the null space. That means like the order minus the rank will give you the null space. So those particular columns will have a relation. Okay, now this analyzing that relation don't have to be like you every time you have to find the rank or everything, that you don't have to do. Sometimes you can just analyze the data through visuals. Okay, for example, you have two variables. Okay, two or three variables or something, and for example, mm, in like, okay, in a salary data set. Okay, for example, you have a data set of salary which is related with the minimum years of experience and what salary you can give to that particular person when that person is joining a company. So this particular um, what you say decision is to be taken by the HR manager. Okay, so a candidate comes with this much years of experience and he has to fix the starting salary of that person depending on one data set. Okay, now so the salary, whatever data that you have already got, the salary and the experience, sorry, the salary will be coming here and the experience will be coming here, and all the data points were like, some values are coming like this. Okay, some values are coming. Okay, so if you could draw some line, straight line, which will fit all these points, then that is that particular relation. Okay, so some relations you have to analyze through visuals. So if you draw this particular scatter plot or something, then you can see the relation, right? So that is one kind of visualization. There are many types, we will see that later. So then discovering patterns, then anomalies also you can spot. Okay, for example, one anomaly that you have seen is here. Okay, that is, and in fraud detection and all, when that particular case, when fraud is happening, there will be like one that will be kind of an anomaly because that will be happening very less number of times. Okay, then you have to form an hypothesis, meaning like this particular value is dependent, the salary is dependent on a particular equation with which has the experience value in that plus some bias value. Okay, so some hypothesis you have to form and then you have to check your assumption. This is like data exploration. Okay, I hope that's clear. Yeah, then feature creation. Feature creation is like if you have some categories like this, then it's like encoding this one. Okay, whenever there is red, that will be one. Whenever there is green, it will be one. Likewise, some new features, increasing the number of features. It's not ideal for every case because usually you'll be looking at decreasing the features, but in some cases, maybe this you'll be doing. Okay. In predictive modeling, data visualization. So one visualization was there before also. This visualization is for showing to your peers or stakeholders using plots and interactive visualization. So this one will be showing your findings. Okay, and that is these things. Other things will go later. So your question, Kangana. These are the different industries. This is a limited list only. Okay, so this is like so you have asked like in supply chain management and other areas like psychology. Yeah, so psychology, since you asked healthcare. Okay, healthcare. So yeah, psychology can be used. Like for example, some things maybe like predicting their mm, levels of depression of a person or detect whether a person is prone to depression or something, seeing the facial features as well as some other things like, yeah, I think I've seen um, something like looking at seizure patterns and all. So it's having huge things in healthcare. Okay, these are the different things for that. Hmm? Then you have asked supply chain management. Yes, retail and commerce. It is there. Supply chain, yeah, it is used there. So I think next class I'll be explaining about these different industries that you'll be using data science. All right, because it's already 9 o'clock right now. Can we get the previous time main exam questions to praxis? I'll just go through that. I don't have the main exam questions right now. Okay, that is not provided to us. Let me see if there is any possibility. Okay, but it's not provided to us, Manmat. Okay, previous videos meaning like last week's your meaning. Yeah, that is. Um, I don't wait. One moment. Mm, just let me just check this one. That problem solving session, I think I have mentioned it that. And then if you are going, my voice is not clear. Is my voice not clear? So this is not updated. Okay, so week 3, I mean this link will, yeah, I'll be updating it. So I something happened there. I think I had already pasted it for week 3. Okay, but it had not come, sorry. So this drive will be having your PPT, right? Okay, so I'll just check that. Okay, so I had already shared it. I mean, it'll be if you, it'll be in the same link. That YouTube link will be in the same channel itself, so you can see that. Okay. Mm, unconstrained Guru, you can just search some YouTube videos for that. Okay, that might be better, maybe. So Manmat, I'll be updating. I mean, I had updated, but it's not coming in your portal. Okay, so let me just see once again. Okay then. Okay, so I hope today's class you have understood? Yes, I'll update.
Yes.
Okay, Ben. Okay then. Yeah. So I'll see every one of you in the next class. Okay. I am Adam. You just go through that announcement sections, okay? There you can see the different things about your course. Okay. And it will be told like you have to register for your exam. You might be getting different reminders and all so that you can see. Okay. Yeah. So, okay, let's start the session for today. Everyone, have a nice rest of the day. Okay. And we will see you the next week. Right? Okay. Thank you, everyone.
Yeah.